So in this example, we're asked to multiply two matrices if possible. So I'm going to check on whether it's possible or not before I bother writing these out. So first checking whether we can multiply in the order A times B. The matrix A has 3 rows and 2 columns, so it's a 3 by 2 matrix. And the matrix B has 2 rows and 2 columns, so it's 2 by 2. So in order for this product to be defined, the inner dimensions here have to match. And so in this case they do. So it is possible to multiply A times B. And the product is going to have dimensions 3 by 2. So I'm going to write this out. So here's the matrix A. First column, negative 1, 3, 0. Second column, 7, negative 2, 3. Times the matrix B. Okay. And I know that the result is going to have, it's going to be 3 by 2, so it's going to have 3 rows. So I'm going to put 3 blanks here, and 2 columns. So it's going to be this size. Now finding the individual entries. When we multiply, we go across the row of the first matrix and down the column of the second matrix. So to get this entry here in row 1, column 1, we should go across row 1 in the first matrix and down column 1 in the second matrix. So multiplying that out, we would have negative 1 times 1 here, plus 7 times 3, going across and down. Okay, now this entry is row 1, column 2. Let me get a different color for the arrows here. So for this entry in row 1, column 2, I'm going to go across row 1 and down column 2 this time. So I'm going to start with negative 1 times negative 2. Negative 1 times negative 2 plus 7 times negative 3. I'm going to run out of room, sorry about this. 7 times negative 3. Okay. Now to this entry, which is row 2, column 1. So I would go across row 2 and down column 1 again. So I would start with 3 times 1. 3 times 1 plus negative 2 times 3. Okay. Let me continue down here. So row 3, column 1. So now I'm going to go across row 3 and down column 1 again. So 0 times 1 plus 3 times 3. Oops. Okay. Last 2 entries. So this is row 2, column 2. So I'm going to go across, give me a little pointer. I'm going to go across row 2 and down column 2. So it's going to be 3 times negative 2 plus negative 2 times negative 3. I'll write that down. I'm going to run out of room. Negative 2 times negative 3. Sorry, this looks pretty sloppy here. Okay, and then last one, row 3 times column 2, because this is row 3, column 2. So row 3, which starts with 0, times column 2, which starts with negative 2, plus row 3, so now I'm up to the 3 there, times column 2, so now I'm at the negative 3. Okay, so cleaning that up, the product A times B, let's see, row 1, column 1, I have negative 1 plus 21, so 20. I'll just go ahead and work my way down column 1. So in this entry, row 2, column 1, I have 3 minus 6, so negative 3. I have 0 plus 9, 2 minus 21 here, So negative 19. Negative 6 plus 6, right, so 0 here, and 0 minus 9 here. So there's the product A times B. Okay, now checking on the product B times A. Is it possible to multiply in the other order? Remember that multiplication is not commutative. Sorry, I need to be clear. Matrix multiplication is not commutative. So we're used to just multiplying real numbers. 1 times 3 is the same as 3 times 1. The order doesn't matter. But in multiplying matrices, the order does matter. In this case, the matrix B is a 2 by 2 matrix, like we wrote above, 2 rows, 2 columns. The matrix A has 3 rows and 2 columns. Since, change colors here, since these inner dimensions do not match, this product is undefined. And that's your answer there. So A times B is this matrix here, B times A is undefined. Looking a little more closely, though, at the B times A is undefined, let me write out. So suppose we actually bothered to copy down B times A. I'll jot those down real quick. 1, 3, 0, 7, negative 2, 3. Okay, here we go. So suppose I actually tried to start working on this product the same way I did up above. So go across the row and down the column, starting with row 1, column 1. Then I would start with 1 times negative 1 plus negative 2 times 3. And then look what happens when you get here. Okay, I still have another entry in the column, but I'm out of entries in the row. So this is maybe gives you a clear idea about why these inner dimensions have to match. The number of columns in the first matrix, I need a third column, would need to match the number of rows in the second matrix, if this is going to be possible. So when these inner dimensions do not match, the product is undefined. If the inner dimensions do match, the product is defined, and the dimensions of your product are going to come from these outer dimensions here. So in this case, the product was 3 by 2.